Explorer 1, NASA's farthest voyaging shuttle, proceeds with its surprising venture through space, delightfully sending important information from the most profound districts of the universe. For almost 50 years, this exceptional space test has changed our comprehension of space. However, as of late, the space apparatus has been sending disturbing information back to Earth, leaving the whole space industry in shock. Are these agitating pieces of information the consequence of a technical breakdown, or the activities of extraterrestrials? Join us as we uncover the truth behind these stunning transmissions. Since the very beginning, researchers have been dazzled by the secrets that lie beyond our divine lines. This curiosity prompted the notable launch of the Explorer 1 and Explorer 2 rockets, among other surprising space missions. These notable missions, which have been studied for a long time, began with the launch of Explorer 2 from NASA's Kennedy Space Center on August 21, 1977. 14 days later, on September 5th of that very year, Explorer 1 followed suit. These twin tests, each weighing a significant 720 kilograms, comparable to a small vehicle, were propelled into space during an extraordinary arrangement of the outer planets. Throughout their fantastic odyssey, these gutsy adventurers explored different directions and speeds, leading to a crucial moment on December 15, 1977, when Explorer 1 outperformed its indistinguishable twin because of variations in their paths. From that point forward, Explorer 1 has become a significant asset, providing us with a wealth of information and unraveling space-related secrets. Before we delve into Explorer 1's frightening new discovery that stunned the whole space industry, let's explore the astounding images captured by the shuttle during its earth-shattering Jovian imaging mission in 1978. Explorer 1 was positioned roughly 265 million kilometers from Earth. From this vantage point, it sent a stunning number of photos back to Earth. In January 1979, it embarked on an unprecedented 100-hour try, capturing hypnotizing time-lapse film showing 10 turns of Jupiter. A cornucopia of 3,750 pictures allowed us to observe Jupiter's grand dance in clear detail. In the ensuing months, Explorer 1 wandered through the Jovian moon system, where it made a surprising discovery: the presence of a humble ring surrounding Jupiter, along with 2 new moons. These findings were drawn out into the open, further expanding our understanding of Jupiter's exciting domain. To ensure safe entry and prevent a potential crash with Titan, one of Saturn's moons, remedial moves were executed. Explorer 1 continued its divine journey around Saturn, revealing 4 additional moons: Mimas, Enceladus, Tethys, and Dione. With the completion of the Saturn mission, researchers decided to close the Explorer planetary mission, moving both Explorer 1 and Explorer 2 beyond the bounds of our planetary system, jumping through space at a shocking velocity of 325 million kilometers each year. In January 1990, a new chapter began with the Explorer Interstellar mission. During this stage, Explorer 1 delivered some of the most famous photos in history, deifying the Sun and most of the planets. One person who played a crucial role in expanding the missions beyond their initial targets was the famous astronomer, Dr. Sean Artley. As part of the Explorer mission's imaging team, Artley championed the idea of capturing one final set of pictures, a farewell gift to humankind. Against all odds, his persistent determination bore fruit. On February 14, 1990, Explorer 1, positioned 6 billion kilometers from the Sun, set out on a visual excursion commonly known as the family picture to capture what is now known as the iconic portrait of our solar system. These amazing pictures, totaling 60 in number, added to the shuttle's impressive collection of 670 photos during its encounter with Neptune. Voyager 2 achieved an unprecedented accomplishment by recording wind speeds exceeding 13,100 miles per hour, making it the fastest wind ever recorded within our planetary system. As the shuttle wandered within 280 miles of Neptune's purplish-blue methane-rich atmosphere, it provided extraordinary insights into this distant celestial body. Remarkably, Neptune's largest moon, Triton, was revealed as one of the coldest objects in our solar system, with surface temperatures plummeting to a frigid minus 391 degrees Fahrenheit. Triton's strange features, such as its nitrogen gas-spewing ice volcanoes that launched cold particles 5 miles into its tenuous atmosphere, further captivated our imaginations. These phenomenal revelations expanded our understanding of the vast variety and complexity of celestial objects residing in the farthest reaches of our solar system. But don't go anywhere. The Explorer-1 space apparatus has recently made one of its most startling discoveries in the entire history of space exploration. Let's find out what it has accomplished in the last 45 years. The accomplishments of the Explorer twin probes have been nothing short of extraordinary. More than 4 decades ago, their initial observations of Jupiter and Saturn's moons left analysts in awe and shattered previous assumptions about these distant worlds. These moons, once thought to be dormant and heavily scarred like our own moon, turned out to be teeming with geological activity. Explorer 2, in particular, achieved several remarkable feats during its journey. It made history in 1986 by becoming the first spacecraft to fly by Uranus. Just 3 years later, it achieved another pivotal milestone with a flyby of Neptune. To this day, it remains the only spacecraft to have undertaken such a journey. As the Explorer spacecraft continued its voyage, NASA implemented various measures to extend its operational lifespan over the years. Unnecessary parts and heaters were deactivated to conserve energy, ensuring that these brave travelers could continue their mission well into the next decade. Their estimated mission end date is set for 2030. For the scientists and engineers who have been involved in this extraordinary project from the very beginning, the end of the Explorer missions is both a moment of pride and a hint of sorrow. Their unwavering dedication and tireless efforts have far surpassed their original expectations. The wealth of data returned by the explorers has provided crucial insights, fueled numerous scientific discoveries, and sparked the imaginations of countless researchers and space enthusiasts. Explorer 1 and Explorer 2 were no ordinary spacecraft. They were meticulously designed as stable platforms, with a rotation rate more than 15 times slower than the hour hand of a clock. This design decision minimized visual blurring as the spacecraft captured images and data while soaring through the vastness of space. Even before their encounters with the outer planets, their remarkable imaging capabilities began to astonish scientists and the public alike. The spacecraft began transmitting pictures of Jupiter long before reaching the gas giant. These early images, showing swirling clouds and the iconic Great Red Spot, thrilled audiences at NASA's Jet Propulsion Laboratory. However, it was the discovery of active volcanoes on Jupiter's moon Io that truly took the spotlight. Io, slightly larger than Earth's moon, turned out to be the most volcanically active body in our solar system. The spacecraft's instruments detected unusual signals from Io, which were confirmed by the distinctive images they captured: towering volcanic plumes and a surface scarred by volcanic material. One of Io's most prominent volcanoes, Pele, erupted with a force several times greater than Mount Everest's height, covering an area nearly the size of France. While the spacecraft's cameras were eventually shut down to conserve power and memory before their journey into interstellar space, it's important to note that the photographs they captured did not include Mercury and Mars for various reasons. In addition to the Explorer 1 and Explorer 2 interstellar probes, NASA has also operated other notable spacecraft such as Pioneer 10, Pioneer 11, and New Horizons. Explorer 1 passed Pioneer 10 on February 17, 1998, marking the moment when Pioneer 10 became the most distant spacecraft. Explorer 1 continued its solo journey for another 14 years before finally entering interstellar space on August 25, 2012. Although there were no other spacecraft in sight, NASA did not publicly announce this remarkable achievement until 2013. What strategies were used to ensure the success of the Explorer missions? One technique stood out as truly brilliant: gravity assist maneuvers. These maneuvers played a pivotal role in propelling Explorer 1 and Explorer 2 on their daring journey to explore the outer reaches of our solar system. To reach these distant destinations and gather crucial data, the spacecraft required more than just their own propulsion systems. They needed a boost, and gravity assists provided just that. Imagine the two brave spacecraft, Voyager 1 and Explorer 2, setting out on their grand tour through the solar system. Rather than relying solely on their engines, they performed a celestial dance with some of our solar system's heavyweights. This intricate maneuver allowed them to harness the immense gravitational pull of these giants to slingshot themselves along their way. In doing so, they saved precious fuel and gained the speed needed to visit multiple destinations. Let's dive into the basics of gravity assist, also known as a gravitational slingshot. The idea behind this maneuver is to transfer some of a planet's momentum to the spacecraft as it passes by. Imagine Explorer 1 approaching Jupiter, a massive gas giant with a gravitational force to match. Explorer 1 passed Jupiter at the perfect point in speed, allowing the planet's gravity to pull the spacecraft, accelerating it to a higher speed and providing an interstellar boost. Performing a gravity assist requires extraordinary precision. If Explorer 1 had approached Jupiter at the wrong point or speed, the slingshot could have resulted in a misalignment of its intended course. The level of accuracy needed is overwhelming. Nonetheless, the brilliant minds behind these missions successfully executed these gravity assists numerous times, propelling the Explorer spacecraft on a stunning journey through the solar system. For example, Explorer 2 used gravity assists from Jupiter and Saturn to reach Uranus and Neptune, two icy giants that would otherwise have been far beyond the spacecraft's reach. However, gravity assists do have their limitations. The spacecraft can only use this method a limited number of times. This means that after achieving specific objectives, these spacecraft, including Explorer 1, must continue their voyage towards interstellar space. Explorer 1's journey is remarkable not only for its scientific breakthroughs but also for the determination and ingenuity of the people behind it. Now, after over 45 years of unyielding space exploration, it remains one of the most captivating chapters in humanity's quest to understand the cosmos. But what could possibly be the cause of those unusual signals recently recorded by Explorer 1? The truth may be stranger than we imagined. Let's uncover the mystery and decide what future awaits this extraordinary mission. As the decades have passed, the data sent back by Explorer 1 has been analyzed and reanalyzed, revealing new insights about the universe in ways that no one could have anticipated when the mission first began. However, recent transmissions from the spacecraft have sparked a wave of concern and intrigue among scientists. These signals, which were first detected in the outer reaches of the solar system, show irregularities that have puzzled even the most seasoned space experts. The first reports came through in early 2023, when signals from Explorer 1 began to deviate from the expected patterns. The spacecraft, which had been dormant for years, suddenly began transmitting at higher frequencies. The signals were erratic, almost as if something or someone was trying to communicate. Researchers at NASA initially assumed it was a technical glitch or interference from deep space radiation. But as the signals grew more coherent and distinct, a new possibility emerged. The transmissions may not be coming from the spacecraft's instruments at all. Could these signals be a sign of extraterrestrial activity? The idea of contact has always been a tantalizing concept in space exploration, and while most scientists remain skeptical, the unexplained nature of these transmissions has led to a flurry of speculation. Some have suggested that these signals could be coming from a previously unknown phenomenon in deep space, such as a rogue planet or a nearby star emitting strange waves. Others believe that the signals could be a form of cosmic radiation interacting with the spacecraft sensors in a way that has never been observed before. But there's another theory, one that is even more thrilling. What if these signals are the result of intelligent alien life attempting to make contact with us, or more specifically with the Explorer spacecraft? After all, Explorer 1 has been voyaging through the vast, empty expanse of space for nearly half a century. It could be possible that, somehow, its long journey has attracted the attention of another civilization, one that has been monitoring its movements across the stars. Experts in radio astronomy have already begun analyzing the signals using advanced equipment to determine their origin. Teams are running simulations to determine if these signals are natural, such as the result of a magnetar or other exotic space objects, or if they are indeed of artificial origin. Meanwhile, scientists are scouring the data for any patterns that might indicate a language, a form of communication from an extraterrestrial source. The discovery of these strange signals has reignited public interest in space exploration and the search for extraterrestrial life. The possibility that we may not be alone in the universe is an exciting and humbling thought, and it has fueled a new era of scientific inquiry. If these signals truly are evidence of extraterrestrial intelligence, it would mark one of the most significant discoveries in human history, one that could forever change our understanding of our place in the cosmos. As NASA works to decode these signals, plans are already underway for a new mission to explore the far reaches of the solar system and beyond. The success of the Voyager missions, the legacy of Explorer 1, and the recent unexpected transmissions are all leading humanity toward a new frontier of space exploration. Whether or not the signals are truly the result of alien contact, one thing is certain. Humanity's quest for knowledge and discovery is far from over. The mystery surrounding Explorer 1's transmissions may just be the beginning of an exciting new chapter in our exploration of the stars. In the coming months, we may learn more about the nature of these enigmatic signals. Could this be the first step in an interstellar conversation? Or are we simply witnessing the first signs of a natural cosmic phenomenon? Whatever the answer may be, one thing is for sure. The mystery of Explorer 1 and its unexpected discoveries will continue to captivate our imaginations for generations to come. The secrets of the universe are vast and still largely untold. But with each new discovery, humanity moves ever closer to understanding the cosmos in all its awe-inspiring complexity.